Okay, so we've been doing some work here. Let's continue through this page and then I'll try to tie everything together. So we're going to make a Q matrix, and I often like to put a little subscript on him. I'm going to call him B to B prime, and we're going to make this Q matrix be the matrix that we found with these guys right here. So the I vector with respect to the B basis is 1/3 and -1/3 with respect to the B prime basis. So we're going to put that into a matrix here as columns. Okay. And the J vector was 2/3 and 1/3. Okay. And I'm going to put this into my calculator. I'm going to call him in my calculator B because I already called matrix A from up here. Okay. Now I'm going to put in as matrix C the column vector 4, 1. And then let's take this guy right here, 1/3, 2/3, -1/3, 1/3 as rows. And let's multiply him by the 4, 1 column matrix. Notice that this is okay because we're doing a 2 by 2 times a 2 by 1, and that should give us a 2 by 1. So we're going to get 4/3 plus 2/3, which is 6/3, also known as 2, and -4/3 plus 1/3, which is -3/3, also known as -1. So what does this have to do with anything? Well, let's go back and remember our picture from the front page here. So we had the point 4, 1, okay? And to get there, we did 4 of the I vector plus 1 of the J vector, okay? But if we wanted to use our blue vectors, I did 2 of the first V1 vector minus 1 of the V2 vector, okay? So that basically tells us that the coordinates of the 4, 1 vector with respect to the B basis is equal to the coordinates 2, -1 with respect to the B prime basis. So to do 4 i's plus 1 j is the exact same location as 2 V1s minus V2, where V1 and V2 were our other basis, not the IJ basis. Okay, so we can think of 4, 1 as the coordinates of vector W, but with respect to the B basis. And when I multiplied by this special Q matrix that I found, by taking and finding the B basis vectors as linear combinations of the B prime basis vectors, you'll notice that it takes the coordinates from the B basis and gives us back the coordinates in the B prime basis. So this is our change of basis problem. Now that we've done all the algebra, we can see how it all works out together. And just as a quick thing right here, to make the I vector, we do 1/3 of the V1 vector minus 1/3 of the V2 vector. So to get this guy right here, we do 1/3 of this guy minus 1/3 of that guy, and that would put us right here at the I. And to get the J vector, by the way, we do 2/3 of this guy plus 1/3 of the second vector, and that will put us right where we need to be. Okay. So notice that we went from the B coordinates to the B prime coordinates here. Okay, and I called that matrix Q. Could we find the matrix that will transition us from the blue basis vectors, the V1, V2 basis vectors, back to the red IJ vectors? And the answer is yes. I'm going to let you think about it for a minute, and we'll pause the video while you do that, and then we'll come back and talk together. All right, hopefully you took a minute and found out that to get the P matrix, it's going to take us from the B prime V1, V2 system back to the B IJ system. We're going to need to take those B prime vectors, basis vectors, and write them as a linear combination of the B basis vectors. So in other words, I want vector 1 to be some linear combination of I and j, and vector 2 to be some linear combination of I and j, which sets up this system, which is already in reduced row echelon form. So I know what the linear combinations are, and we'll talk about that in just a second. So my P matrix that will take me from B prime coordinates back to B coordinates is this guy, 1, -2, 1, 1. Okay, and just to show that, if I take this guy and I multiply by the location of 2, -1 with respect to the B prime coordinates, we get 2 plus 2, which is 4, and then 2 minus 1, which is 1. And so you can see that we get the same location, but with respect to the other basis. Okay. Now, why did this work out so nicely? Well, when I told you the V1 and V2 vectors, I had to communicate to you. Whoops, sorry, I grabbed the wrong paper here. So that's the one I wanted to talk about. So literally, when I told you V1 and V2, I told you 1, 1, 1 and -2, 1. So to communicate, I have to use some kind of language. And we've kind of set this up as a default using our standard basis is kind of like, for me, since English is my first language, like using I and J. So you'll notice that this literally was written in terms of my English language, 1, 1, plus -2 of these and 1 of these to make these guys. So it's like saying that this is English and I need to convert to Spanish. Okay, that was my first foreign language, was Spanish. Okay, and we were able to do that. Now, what happens though if we have a situation where we need to convert between two non-standard bases? Okay, so let's suppose now that B is the vector 1, 3 and the vector -1, 2. Okay, now again, notice that I gave these to you in English, but we're going to call this system that it sets up, let me call that Italian. Okay, and then let's keep this guy, the 1, 1 and -2, 1. We've said that he was Spanish, so let's keep him as Spanish over here. And to communicate, I needed to use a language, so I communicated to you what the Spanish vectors were, but I told you what they were in English. And as we notice here, our Italian vectors, 1, 3 and -1, 2, they are not orthogonal and they are not each length 1, so they are not orthonormal. And similarly here, our Spanish vectors are neither orthogonal nor normal, so they're not both orthonormal. Okay, and so if we take a look at the systems that they set up, they're both non-square systems, okay, for the Italian and for the Spanish. And I'm going to help us see this a little bit better. I'm going to superimpose on this the IJ grid so we can see that this is really 1, 1, 2, 3. So here's the vector 1, 3 and -1, 2. So you can see how those are created. Similarly, back over here. Now, let's go ahead and find a vector, the 5, 5 vector. But to tell you the 5, 5 vector, unless I tell you it's with respect to some other basis, we're going to assume it's the IJ basis. So to do the 5, 5 point, or 5, 5 vector, I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And so that would land me right here. Okay. So how could I use my red vectors to get there? One thing I could notice is it is on a crossing of these grid marks. So I'd go like this and like that. So to make that, I would need, let me call this U1 vector and U2 vector. Notice to make this point, I would need to make, or to hit this point right here, I'd need to use 3 of the U1 vectors with -2 of the U2 vectors. So the coordinates with respect to this B basis are 3 and negative 2, because we go in the order. So how many of the first vector do we need? I could have gone up like this and then come back. It was just a little easier to see like this. Okay, so I'm actually going to pause right there so we can keep our videos about 10 minutes and pick up in the next one.